So we're going to jump into chapter 1, which is a chapter on factoring. And factoring is more or less rewriting a problem, as a product of a couple of factors, for the lack of a better definition. And the first concept that we're going to get is a concept called the greatest common factor. And before I try to define it, let me do it just by an example. If I give you a set of numbers and I say find the greatest common factor, usually I abbreviate greatest common factor as GCF. If I give you a couple numbers and I ask you to find the greatest common factor, like if I give you the numbers 20 and 16, the greatest common factor is the biggest factor that these have in common. Because we need to know factors quickly in this chapter, I made a list of factors, and I'll quickly find the factors of 16. The factors of 16 are all the numbers that divide evenly into 16. So the factors of 16, the numbers that divide evenly into 16 are 1, 2, 4, 8, and 16. Those are all the numbers that if you did 16 divided by any of those, you wouldn't get a fraction. The factors of 20 are 1, 2, 4, 5, and 20. So if I know the factors of a specific integer, then I could find the greatest common factor, greatest meaning largest, common mean they have in common. 1's a common factor of 16 and 20 because it's factors of each. 2's a common factor of 20, it's a factor of each. 4's a common factor, but there isn't a bigger common factor. So I might say the GCF of the numbers 20 and 16 is 4. That's the biggest number that divides evenly into them. If I say find the greatest common factor and I give you 3 numbers, say let's give you 24, 40, and 8. Well, let me look at the factors of 24. The factors of 24 are a monstrous list. 1, 2, 3, 4, 6, 12. I think I missed 8 on there because 8 times 3 is 24. I made this real quickly and I might have forgotten some. I'll insert them as I figure out what I forgot. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Those are all the numbers that if you do 24 divided by that number, that you won't get a fraction. If I look at the factors of 40, the factors of 40 are 1, 2, 4, 5, 8, 10, 20, and 40. So 1, 2, 4, 5, 8, 20, and 40. And then lastly, the factors of 8 are 1, 2, 4, and 8. If I know the factors of all the numbers, then it's not a particularly challenging activity to find the greatest common factor. 1's a common factor, 2's a common factor, 4's a common factor, 8's a common factor, and it's the biggest common factor. So I might say the greatest common factor between 24, 40, and 8 is 8. It happens to be one of the numbers. That's going to be an important skill in this section. If I asked you to find the greatest, first find the factors of x to the 4th. The factors of x to the 4th are all the items that would divide by x to the 4th without a remainder. It would be 1. 1's a factor of everything. And then x to every power be up to and including 4. So x to the 1st, x to the 2nd, x to the 3rd, and x to the 4th. Those are all the factors of x to the 4th. If I did x to the 4th divided by any one of these 5 items listed, I wouldn't get a fraction. If I say find the factors of x cubed, the factors of x cubed are 1, and then every power of x up to and including x cubed. So for letters, factors are kind of trivial in some sense. If I asked you to find the greatest common factor between x to the fourth and x cubed, well, I'll look at their factors. The greatest common factor is the biggest power of x that they have in common as their factors. That's going to be x cubed. Similarly, if I say find the factors of x and find the factors of x squared, the factors of x are just 1 and x. The factors of x squared are 1, x, and x squared. The greatest common factor between x and x squared is x. So we're going to need the concept of greatest common factor. The greatest common factor of a set of numbers is the largest number that divides into the numbers evenly. The greatest common factor of a common letter is the biggest exponent, or it's the smaller of the exponents, should I say. So this is an important factor. The greatest common factor between a group of numbers is the largest number that divides evenly into the numbers. The greatest common factor between a group of common letters is the smaller of the exponents. The greatest common factor between x to the fourth and x cubed is x cubed. The greatest common factor between x to the first and x squared is x to the first. So in section 1.1, the instructions for the first 16 problems are to factor. And factoring is asking me to rewrite the problem with a parentheses. Actually, factoring the common factor involves first identifying the greatest common factor and then rewriting the problem with the greatest common factor in front of a parentheses. So a greatest common factor can be a number, a letter, or just a number, just a letter, or a combination of a number and a letter. In problem 2, to find the greatest common factor so I can factor it out, I look at the coefficient 6 and the number 12 without worrying about the minus sign. And I look at the factors of 6. The factors of 6 are 1, 2, 3, and 6. I look at the factors of 12, which are 1, 2, 3, 4, 6, and 12. The greatest common factor between 6 and 12 is the number 6. It's the biggest factor that they have in common. Because both terms don't have an x, or don't have the letter x, the greatest common factor doesn't have an x. In order to find the greatest common factor between letters, you need at least 2 of those letters. You could have 3 of those letters. So in this particular problem, number 2, the greatest common factor is just the number 6. I'm going to rewrite this problem with the greatest common factor in front of a parentheses, and inside the parentheses, I'm going to write something that would multiply back to the original problem if I clear the parentheses. And so inside the parentheses, I'm going to take both of the original pieces to the binomial, and in my mind, divide them by 6. But for now, I'll show it physically. The number that I put in front of the parentheses, the greatest common factor, I'm going to divide by each of the original terms. When I divide 6x by 6, the 6's cancel and I just get x. I'm going to divide minus 12 divided by 6, and that's going to give me minus 2. I would claim that this is an answer. This is doing factoring by factoring out the greatest common factor for number 2. And that parentheses looks so far away, I'll pretend it wasn't there. Now, if I want to check, I clear the parentheses, and when I clear the parentheses, it should come back to the original problem. To clear this parentheses, I have to distribute and do 6 times x and 6 times minus 2. 6 times x is 6x. 6 times minus 2 is minus 12. Because that is exactly the original problem, I know I factored correctly. Moving on to number 4, I need to find the greatest common factor. So I need to know the factors of 25, the factors of 20, and the factors of 5. I have them in my head, I know them, but the factors of 25 are 1, 5, and 25. In case you don't know those in your head, a lot of students can just look at these and know the greatest common factors, but if you can't, I'll do it this way. The factors of 20 are 1, 2, 4, 5, and 20. And the factors of 5 are just 1 and 5. So the greatest common factor number part is going to be the number 5. It's the biggest factor that they have all in common. The factors of y cubed are 1, y, y squared, and y cubed. The factors of y squared are 1, y, and y squared. And the factors of y are just 1 and y. The greatest common factor, the y with the highest exponent that all the factors have in common, is the y to the first power. If each term has the same letter, the common factor is the smallest exponent. So now I'm going to rewrite this problem. I'm going to create a parentheses, and I'm going to put the common factor of 5 and y to the left of the parentheses. And then inside the parentheses, I'm going to divide each of the terms in the original problem by 5y. I'm going to take the 25y cubed, divide it by 5y. I'm going to take the minus 20y squared, divide it by 5y, and I'm going to take the 5y and divide it by 5y. First division, 25 divided by 5 is 5. I'm going to put that first in my parentheses. I'm going to subtract the exponents of the y's. 3 minus 1 is 2, and I'm going to get a y squared. Next division, negative 20 divided by 5 is negative 4. I'm going to write that next in my parentheses. I subtract the exponents on the y's. 2 minus 1 gives me a y to the first. Last division, anything divided by itself is 1. I need a sign between each of the terms, and since that's plus, I'm going to put a plus 1. Claim that's my answer for problem 4, and I'm going to check. To check, I'm going to clear the parentheses that I just created. I'm going to go 5y times 5y squared, and then 5y times minus 4y, and then 5y times positive 1. The first multiplication, I multiply the 5 times 5 and get 25. I add the exponent of 1 and 2 on the y's and get a y cubed. Next multiplication, 5 times minus 4 is minus 20. I add the exponents on the y's, 1 plus 1, and get a 2. Last multiplication, I do 5 times 1 and get a 5. And I leave the y. I look at this. I compare it to the original problem. Because that's exactly the original problem, I know my answer is right. Moving on to number 6, the first two terms don't have coefficients, or they have an implied coefficient of 1. So my common factor is not going to have a number. In order to get a common factor of a number, you can't have a coefficient of 1, because the only factors of 1 are 1. So my common factor for number 6 is just going to be a letter. And the efficient way, if you look at a polynomial that you're asked to factor, you look at if they all have the same letter, the common factor is the smallest exponent of those letters. In problem 6, I have an exponent of 3, an exponent of 2, and an exponent of 1. The common factor is going to be x to the first. So I got real formal in figuring out what goes inside the parentheses for my first two examples. Realistically, that's not, the best practice. Coming out with a way to do this in your head is probably better. So I'm going to try to start to do that. For this particular problem, I factored out an x. I want to figure out what to load up my parentheses with. The first term had 3 x's. I took 1 x away. I'm going to be left with 2 x's. I'm going to carry down the minus sign. The second term had 2 x's. I took 1 x away, so in the middle I'm just left with 1 x. I'm going to bring down my plus sign. The third term had both a 9 and an x. I took the x away, so I'm just left with the plus 9. Claim that's the answer for number 6. I could check, but it takes so long to check, and I'm pretty comfortable with that work, so I'm not going to check it. But you could check by distributing and clearing the parentheses. For number 8, the second term has a coefficient of 1. So anytime one of the terms has a coefficient of 1, there isn't a number for the greatest common factor. Both terms have a y. The greatest common factors when each term has the same letter is the smaller of the exponents. So the greatest common factor for number 8 is going to be y squared. That's the smaller of the exponents. And now to figure out what goes inside, the first term had a 3 along with 3 y's. I didn't factor out a number, so that 3 is going to stay there. It started with 3 y's. I took 2 of the y's away, so I'm going to be left with 1 y. I'm going to carry the minus sign, and anytime I factor an identical term out, I have to be left with a 1 behind. So I had a y squared after the minus sign. I took the entire y squared away. Anytime I left, if I take the entire factor away, I need to leave a 1 behind. If I want, I can check this just to show you that that strategy works. Because the original problem had 2 terms, my parentheses needed to have 2 terms. So to check, I would take the y squared in front of the parentheses, multiply it by both the 3y and by the negative 1 inside the parentheses. This first multiplication, the 3 just tags along, and I add the exponent to the y. 2 plus 1 is going to give me a 3. The second multiplication, positive times a negative is a negative, and I can just leave the 1 and the y squared next to each other. I get this when I multiply, and I claim that's really the same as that because this coefficient of 1 is not really necessary. So I've checked and I feel good about my answer. Even though I don't have an exact match, I understand that that's equal. All right, so for 10, I have a number 15 and a number 10. I know that the common factor of those is a 5, but I'll do this from this. 15, the factors are 1, 3, 5, and 15. And for 10, the factors are 1, 2, 5, and 10. So the common factor, or the greatest common factor, is going to be 5. So in front of a parentheses, I'm going to put a number 5. And now I look at the variables. Both on either side of the minus sign, there's x's on each. Since they both terms have an x, I take the smaller exponent, which is an x cubed. And on either side of the minus sign, each term has a y. I have a y squared and a y to the 4th. The smaller exponent's the y squared. So now I've figured out my common factor. Inside the parentheses, I'm going to divide any number that I see by 5, take 3 x's and 2 y's away. So this first 15, because I factored a 5 out, I'll divide the 15 by 5 and get a 3. This x to the 4th, I took 3 x's away, and 4 minus 3 is 1. I'll be left with 1x. And the y squared, I took the entire y squared away, so I don't need a y. I'm going to bring down the minus sign, and then after the minus sign, I started with a 10. I factored out a 5. 10 divided by 5 is 2. I had an x cubed. I took the whole x cubed out, so I won't write an x cubed. I had 4 y's. I took 2 y's out. I'll be left with a y squared. This might bug you that it's written not in such a nice order. When I did my common factoring, this is because the original problem was written in a cruddy order. This is a 6th degree term. This is a 7th degree term. My parentheses has a 1st degree term and a 2nd degree term. If this bugs you, you can rewrite that parentheses, but I generally wouldn't. If somebody wrote a problem in a wrong order, they're probably okay with that wrong order. But I might write negative 2y squared plus 3x. It's equivalently correct. So for 12, I need to look at the factors of 32 and the factors of 24. So the factors of 32 are 1, 2, 4, 8, 16, and 32. The factors of 24, if I didn't miss them, are 1, 2, 3, 4, 6, 12, 24, and I forgot the 8. I tacked it on at the end. So it's really 1, 2, 3, 4, 6, 8, 12, and 24. So it's nice to have a listing of all the factors. You might want to just pause the video if you're not good at common factoring and write some of these down if you can't get them in your head, by yourself. So for the common factor, the largest common factor, numerically it's going to be an 8. So in my answer, I'm going to put an 8 to the left of a parentheses. Now I start digging through the letters. Each term has an A. The first has 2 A's, the second has 1 A. The common factor is the smaller exponent, which is 1 A. And then I get onto my B's. The first has 6 B's, the second has 7 B's. I take the smaller, which is 6 B's. Inside my parentheses now, I'm going to divide each of the numbers by 8. I'm going to take 1A and 6 B's away. So for the first 32, I divide 32 divided by 8, and 32 divided by 8 is 4. I have 2 A's. I took 1A away, so I'm going to be left with 1A. I had 6 B's. I took all 6 B's away. I'm not left with a B. After the minus sign, the 24 that I start with, I divide by 8. 24 divided by 8 is 3. After the minus sign, I had 1A. I took the 1A away. I'm not left with an A. I had 7 B's. I took 6 B's away. I'm left with 1 B. I feel that's probably the best answer for 12. 14, I start looking at the numbers. So the coefficients of 15, 9, and -6, I won't worry about the sign. And 6, I need to get the factors. For 15, it's 1, 3, 5, and 15 as the factors. For 9, it's 1, 3, and 9 for the factors. And for 6, it's 1, 2, 3, and 6 for the factors. So I look at my factors, and 3 is the common factor that's largest. So when I start to write my answer, I'm going to put a 3 in front of a parentheses. Now I go one letter at a time. I look at the x's. There's an x cubed first, an x squared second, no x in the third parentheses, so I don't get an x in my common factor. All the terms have to have a letter for that to be part of my common factor. Now I'll move on to the y's. First term has a y to the first. Second term has a y to the third. Third term has a y to the first. All 3 terms have y's. I need the smallest of the exponents, which is the y to the first. Move on to the z's. First term z to the first. Second term z squared. Third term z to the first. They all have z's. I need the smallest exponent, which is z to the first. Make my parentheses. Bring this plus and minus sign down. Now I'm going to work on the first term. I'm going to divide the 15 by 5 and get a 3. 15 by 3 and get a 5. I'm going to leave the x cubed because I didn't factor out any x's. I'll take the 1y away and the 1z away, so those will be gone. So inside the parentheses, I'll lead with a 5x cubed. After the plus sign, this 9, I'll divide by that 3, and 9 divided by 3 is 3. Oh, I didn't leave myself enough room. I didn't do anything with the x squared, so I'm going to leave it there. It had 3 y's. I factored out 1, so I'm left with 2 y's. It had 1 z. I factored out 1, so I'm left with 1 z. So this should be, let me just write it more clearly. It's 3yz times 5x cubed plus 3x squared y squared z. And then after the minus sign, this 6 I divide by that 3, or minus 6 divided by 3, and I get minus 2. I took the y and the z away, and it didn't have any x's, so that's just going to be this. These are both the same. One's just written slightly better than the other. All right, 16, I look at the numbers 8, 6, and 10. The factors of 8 are 1, 2, 4, and 8. The factors of 6 are 1, 2, 3, and 6. And the factors of 10 are 1, 2, 5, and 10. I'm kind of not worried about the signs right now. So the greatest common factor numerically is the number 2. It's the biggest number that divides evenly, or that's a factor of each of the terms. So here, look at the letters. First term has r cubed, second term r cubed, third term r to the first. They all have r's. I take the smaller exponent. Moving on to the s's. First term s to the first, second term s squared, third term s to the first. They all have s's. I take the smallest exponent, which is just an x, s. And then the t's. First term t squared, second term t to the first, third term t to the first. They all have t's. I take the smaller exponent. To fill up my parentheses, I divide each of the numbers by 2, take one r, one s, and one t away. First 8, when I divide it by 2, I get 4. The first 3 r's, I took 1 away, so I'm left with 2 r's. Took that s away, so I don't need to worry about it. From the 2 t's, I took 1 away, I'm left with 1 t. Bring down my plus sign. After the plus sign, this 6 divided by that 2 is going to be 3. It had 3 r's, I took 1 away, I'm left with 2 r's, which is going to be an r squared. It had 2 s's, I took 1 away, I'm just left with an s. It had 1 t, I took it away. After the minus sign, this 10 I divide by 2 and get 5. And I took all the r, the s, and the t away. So this is a good answer. It's checkable. I generally don't check these unless I'm just, really feeling uncomfortable about what I did. So I'm going to pause and we're going to do a part 2, hopefully not a part 3, but maybe a part 3.